Although it may have seemed like some kind of magic when you were a little kid, there is a reason behind why water falls from large white clouds, why puddles disappear from the road, and why your hand becomes wet when you put it over a pot of boiling water. These are all examples of what scientists call phase changes, and they're very important while studying chemistry. There are 6 types of phase changes that describe the transformation of a substance between its solid, liquid, and gaseous forms. There are 2 types of changes between the solid and liquid phase: melting, where a solid becomes a liquid, and freezing, where a liquid becomes a solid. There are many examples of this phase change, but the easiest to think about is the relationship between ice and water. When you put ice in a cup of water, it melts to form more water. If you happen to make ice cubes at home, you would know that when you put water into an ice tray and stick it in the freezer, you will find ice cubes in the tray the next day. The next 2 types of phase changes involve the relationship between the liquid and gaseous phase. During vaporization, a substance changes from the liquid form to the gaseous form, while during condensation, a substance goes from the gaseous form to the liquid form. I mentioned 2 examples of vaporization earlier when describing the evaporating water in a puddle and boiling water in a pot. Condensation is one of the most recognized processes that is part of the water cycle. Rain. The water cycle is actually a great representation of the phase changes of water. After it rains, water drains into oceans where it evaporates and forms clouds. Then the water condenses and falls back to Earth as rain, and the cycle begins again. The final 2 relationships that I will talk about are sublimation and deposition, during which a substance shifts between the gaseous and solid phases. Sublimation is the change from solid to gas, and deposition is the change from gas to solid. Dry ice is a great example of the sublimation of carbon dioxide. An example of deposition, referring back to the water cycle again, is how snow forms in clouds. The most important part of phase changes is understanding how every phase change is accompanied by a change in the energy of the system. The relationship between phases and energy is crucial. Let's think about this a little bit. We know that increasing temperature increases the energy in a molecule. This makes sense because temperature is a measure of the heat in a system. This means that a molecule generally moves much faster. If you think about a hard tabletop, it's a solid. It is sturdy and generally pretty durable. It does not break apart easily. The molecules of a solid are densely packed and do not move around very much. This is one specific scientific reason that we can't walk through walls, for example. An increase in energy, an increase in temperature is what causes changes in phases. Now, there are very specific terms that describe the energy needed to change from solid to liquid to gas. As the temperature of a solid increases, the units of the solid become less condensed and more freely moving. There is more energy in the molecules, and the substance enters the liquid phase. The energy needed to successfully change from solid to liquid is called the heat of fusion. It's important to note that the heat of freezing, which refers to the energy required to go from liquid to solid, is always the same value as the heat of fusion. However, one process is exothermic, while one is endothermic. Moving on. Now, while studying right now, you may be drinking a soda, or juice perhaps. This is a liquid. It flows easily and forms to the shape of its container, like a glass cup. The molecules are still close together. However, the increased distance between molecules due to more rapidly moving particles explains why liquids appear as they do. There is technically more energy in a liquid than in a solid. This is why liquids exist at higher temperatures than solids. Heat of vaporization refers to the energy required to cause a transition between liquid and gas. The opposite, heat of condensation, refers to the energy required to cause a transition between gas and liquid. Now let's look at gases. Molecules and gases are much farther apart than in either a liquid or a solid. When you think about gases, as in a balloon, they have indefinite shape and indefinite volume. They expand to fill their containers. Molecules are rapidly moving in many directions. There is more energy in gaseous molecules than in either liquid or solid structures. This is why gases occur at the highest temperatures. Heat of sublimation, denoted by delta H sub, is the amount of energy needed to go from solid to gas. The opposite, heat of deposition, is the amount of energy needed to go from the gas to the solid phase. There are 2 important graphs that we can look at while examining phase changes: the heating curve and the phase diagram. Let's first look at the heating curve. The heating curve shows the relationship between temperature and the heat added to a substance. This particular graph is a representation of water. Now, the blue lines represents the temperatures and amount of heat at which a substance is in a specific phase. For example, from A to B, water is in ice, it is in its solid form. From C to D, it is in its liquid form as water, and from E to F, it is in its gaseous form as water vapor. Now the red lines, which are important, are the areas at which a substance is undergoing a phase change. So from B to C, ice is forming to liquid water. It is melting. As heat is added, it is going from ice to water. From D to E, as more heat is added, it is undergoing vaporization from liquid water to water vapor. The second graph we're going to look at is a phase diagram. A phase diagram is a graphic way to summarize the conditions under which equilibria exist between different states of matter. This diagram helps us predict the phase of a substance that is stable at any given temperature and pressure. Now, it's important to note where the solid, liquid, and gaseous forms are. Whenever you have a Y graph like this, your solid is going to be all the way to the left. The liquid is going to be in the middle of the Y, and the gas will be towards the bottom of the graph. There are a couple important points to note while looking at a graph such as this one. The triple point, located somewhere near the middle of the graph, is the point at which all three phases are present. This point here, the critical point, is the point at which you are unable to distinguish between the liquid and the gaseous phases. So hopefully this has sort of explained the magic, so to speak, that you thought you saw when you were a little kid. Hopefully you now understand that there's a reason behind why water falls from large white clouds, why puddles disappear from the road, and perhaps why your hand becomes wet when you put it over a pot of boiling water. Phase changes are essential to understanding processes that occur on Earth, and better yet, essential to understanding chemistry. And now I hope you have better knowledge about how they work. Thanks so much.